If you've ever looked at a titration calculation and thought, nope, you're not alone. Hi, welcome back to Caroline's Chemistry. In this video, we're breaking down everything that you need to know about titration calculations, from what a titration actually is, a quick recap of the method, to step-by-step worked examples showing exactly how to tackle the maths. We'll also look at the most common mistakes students make so you can dodge them confidently in your exams. So whether you're revising GCSE chemistry or taking A-level and need a solid refresh, this video will take you from I kind of get it to I can actually do these questions. So don't forget to hit like and subscribe now. Let's grab a pen, maybe a coffee, and let's make titration calculations make sense. So let's start off with exactly what is a titration. What is it that we're trying to do here? So a titration in a nutshell is a really accurate experiment that is done to find out the concentration of an acid or an alkali. Notice the emphasis, it's really, really accurate. So a lot of the steps in the method that we're going to go through next actually come back to that bit. It's about making this as accurate as possible. So a couple of pieces of equipment that you would need or meet when you're doing a titration is a burette. So it's a long glass tube and it has the scale up the side, and then there is a tap at the bottom. What we do with a burette is measure variable volumes of liquid. So for instance, you can measure 5, 6, 7, 10, 20 centimeters cubed. A pipette, on the other hand, is for measuring fixed volumes of liquid. Now that is not like a teat pipette that's often plastic that you might have used in schools. A pipette for titrations is glass. And usually you would have a pipette filler that attaches on the top, and you roll that pipette filler up and it takes the liquid up to the line. Now, usually for a titration, you'd use 25 centimeters cubed as your fixed volume, but pipettes for different volumes also exist. And again, a burette and a pipette add to this idea of a very accurate experiment. Like, you're not going to get great accuracy with a teat pipette. That has a very high apparatus uncertainty. Let's now look at the method. So the method for a titration is about trying to measure the exact volume needed to neutralize your sample, your acid or alkali. And we use an indicator in order to get that exact volume. And we're talking like how exact, how accurate, like one drop will change the color of the indicator, and that's the exact neutralization. So this is your step-by-step method. If you're GCSE, then this would be like a 6-mark question, for instance, that you would state step-by-step. At A-level, quite often, this is a required practical or a core practical, so you might need to go into a little bit more detail. If so, then check out the video that I am going to make or have made, depending on what point you're watching this, for this exact required practical, core practical, with a little bit more detail for A-level. But your method overall doesn't change. It's just about the amount of detail that you might need to talk about. So you would first of all start with placing your acid or alkali into a conical flask using a pipette. So a conical flask is that triangle sort of shaped piece of glassware, using your glass pipette that we talked about on the previous slide. Then you would also place your other chemicals, so your acid or your alkali, into the burette. You're then going to add a suitable indicator. Now, phenol red is going to work for most titrations, but you might also come across like methyl orange, etc., phenol phthalene. But if required to like name an indicator, then you could say phenol red. You're only going to add a couple of drops. You're not adding a lot at all. Then you're going to add your acid or alkali from the burette into the conical flask until the colour changes. You can start by doing this in like quite large amounts, like 2 centimeters cubed, 5 centimeters cubed. But as you approach that endpoint, the point at which the colour of the indicator is going to change, you can do this drop by drop. Then you'll note the final reading, so the volume required to change the colour of the indicator to exactly neutralise your sample, and then you're going to repeat that. And you're going to repeat that for a titration until you get concordant results. So those are results that are within 0.1 centimeters cubed of each other. Once you've carried out your titration, you now have the data needed to do a titration calculation. Now, this is the same method as I teach throughout this entire calculations module, whether that is GCSE or A-level. So the first step is identify your tick and your question mark, the substance that you have some information on, and the substance that the question is asking you about. Second step is to work out the moles of the tick, and that is using your volume equation. I've shown that in the triangle here if that helps you rearrange it. So moles is equal to concentration times volume. Then we'll work out the moles of the question mark using the big numbers, the stoichiometry of the chemical equation. And then finally, we would work out not necessarily the mass in this case, but the concentration or the volume of the substance that you are interested in. Note for me that we do have some standard units in this equation. So volumes are in decimeters cubed, and that's because the standard unit for concentration is moles per decimeter cubed. So if you are given a volume in centimeters cubed, which you are very likely going to be because that is a workable amount to use in a lab, you don't want to be using huge quantities and litres of chemicals, then you are likely going to need to take your centimeters cubed and divide by 1,000 to turn it into decimeters cubed. So for this first part of the method, we are going to work out what is our tick and what is our question mark. So the tick is the substance that you know two things about. So if we have a read of that, then we know the volume of the sodium hydroxide, and we know the volume and concentration of the hydrochloric acid. So that makes hydrochloric acid our tick, and we can start to fill that straight away perhaps. So I'm going to create my table with concentration, volume, and moles down the side. And you can always pop them in that order because it means you're not having to think too much about how to switch in between the two, how to work out between the two. Let's add in our concentration of hydrochloric acid. So that is 0.100. And the volume of the hydrochloric acid is 25 centimeters cubed. But remember, standard units here for concentration are decimeters cubed. So we're going to divide that by 1,000. We can now work out, second step of the method, the moles of the tick by using this concentration and volume. So concentration times by volume is equal to moles. So if we pop that into the calculator using brackets where needed, then we get 2.5 times by 10 to the minus 3. The third step of the method is now to work out what our question mark is, the moles of our question mark. Now the question is asking us to calculate the concentrations of sodium hydroxide. So that's our question mark. In order to switch columns from the tick to the question mark, we use the big numbers. There are no big numbers here, which means they're all ones. This is a 1-to-1 ratio, meaning 2.5 times 10 to the minus 3 moles of hydrochloric acid will react with 2.5 times 10 to the minus 3 moles of sodium hydroxide. Now we work up the column to work out the concentration of the sodium hydroxide. Now we're already told the volume. The volume of the sodium hydroxide is 22.5 centimeters cubed. Again, convert that into decimeters cubed by dividing by 1,000. In order to go up the column, then we do the moles divided by the volume. We're going up. So I do 2.5 times 10 to the minus 3 divided by 22.5 over 1,000. Once we put that into our calculator, we get a concentration of 0.111, and that's the 3 significant figures like the question is asking us for. And then finally, don't forget units for your final answer. There we go. So what we do first is to identify our tick and question mark. For that, let's look at the data that we have in the question. So we have a volume and a concentration of sodium hydroxide. So because I know two things about that, that is my tick. Let's start to put those in already. So I'm going to create my table down the side here. So concentration, volume, and moles. Always pop it in that order because it makes the calculation Nice and simple onwards. So our concentration of sodium hydroxide is 0.150. I'm going to keep all the significant figures there. The volume is 30 centimeters cubed, but I want to change that into decimeters cubed, so divide it by 1,000. The question is asking us to find the concentration of the acid. So yes, even though we have the volume of sulfuric acid, the question is asking us about the acid. Let's make it our question mark. Okay, now let's work down the column of the tick. So concentration times by volume is equal to moles. So if we pop that into our calculators, make sure you use brackets where appropriate. Then we get 4.5 times by 10 to the minus 3. So that's the moles of the sodium hydroxide. Now, I want to find out the moles of the tick. In order to do that, to switch columns, we have to use the big numbers. So there is a big number in front of the sodium hydroxide, it's a 2. And there's no number in front of the sulfuric acid, that means it's a 1. So that's a 2-to-1 ratio. I'm going from 2 to 1, so I'm dividing by 2, 2-to-1 ratio. So if I take the 4.5 times 10 to the minus 3, halve that, I therefore get 2.25 times by 10 to the minus 3. Now we can work up this column to eventually find the concentration of the acid. So we know the volume of the acid, that was 5 centimeters cubed. Again, I'm going to turn it into decimeters cubed and divide that by 1,000. In order to work out concentration, then it is moles divided by volume. So I do 2.25 times 10 to the minus 3 divided by 5 over 1,000. Again, use brackets on your calculator to put this in. That therefore gets us to 0.450. I'm keeping the same number of significant figures as the data in the question, and that is moles per decimeter cubed. Now, if you are GCSE, 0.450 is fine as your answer. If you are A-level, you'll need to have a closer look at those significant figures because the volume of sulfuric acid is actually 2 significant figures. So A-level students would be required to give that answer to 2 sig figs, 0.45 moles per decimeter cubed. Okay, so there is our concentration moles per decimeter cubed. I'm also asked to work that out in grams per decimeter cubed. So let's skip back now to our other equation. So mass is equal to Mr. moles. Why are we using this equation? Because we have moles per decimeter cubed, and I want to turn that into a mass, grams per decimeter cubed. So all I'm going to do is take that concentration, 0.450, the moles per decimeter cubed, and times it by the MR of the sulfuric acid. So let's use the periodic table to work out that MR. We have 2 lots of 1 for the hydrogen. We have 32 for the 1 sulfur, and we have 16 times 4 for the oxygen. So that overall MR is 98. So I do 0.450 times by the 98, which gives us our second answer, 44.1 grams per decimeter cubed. Again, if you are GCSE, then that number is absolutely fine as is. If you are A-level, again, think about those significant figures. Because the volume of the sulfuric acid is the lowest number of sig figures in the original data, you would have to give that as 44 grams per decimeter cubed. So finally, let's look at some common places where people lose marks. So see if you can avoid these mistakes. Make sure you are rearranging the equation correctly. And that includes in that table method that I've just shown you in the previous worked examples. Make sure that you know what it is that you're timesing by, that you're dividing by, etc. Double check that. I like to remember that equation as N equals BC and then rearrange from there, but you use the method that works best for you. Second point that people lose marks on very, very often is to forget to convert into those standard units. Yes, I bang on about it. It's because it's important. It doesn't matter if your overall answer is correct if you haven't actually converted the units properly during the method. So really, really important. If you are A-level, do consider the appropriate number of significant figures for your final answer. And this bit is appropriate to whether you're GCSE or A level. Do not round your numbers in the middle of a calculation. Keep the number as long as you possibly can, the whole number. If you're A level, do give your answer to the lowest number of significant figures in your original data. So that is because you can't give an answer that is more precise than the data that you were given. If you are GCSE, then sometimes the question will ask you, like, give your answer to 3 significant figures, in which case that's all you need to worry about. And finally, only use the big numbers, the numbers in front of the chemical formulae, otherwise sometimes known as like the stoichiometric numbers or the stoichiometry if you're A level, when you're switching columns in your table. So never use them to work out moles and don't use them to work out MRs. You're only using those when you're converting like the number of moles of your tick to the number of moles of your question mark.
Thanks for watching. If this was helpful, don't forget to hit like and subscribe now so that I can help you along your GCSE or A-level way and get the grades that you deserve.